Okay, welcome back to COSC 1436, C++ programming. This video is going to cover chapter 1. And so let me go ahead and share my screen. I'm going to show you the PowerPoint. And I'll go ahead and share the slides now. Okay, so this is chapter 1, Introduction to Computers and Programming. All right, so this is some terminology, basically difference between computer program and programmer. So you've got your computer, and basically a computer is nothing without a program, and the program is created by a programmer like you and I. So you will be a programmer, and the computer is only as good as the program. It's what you have to remember. Okay, so these are the main components of a computer, and this is important because when you write a program, these are some of the things that you have to think about. So we have the central processing unit, main memory, secondary memory storage, input and output devices. This is a picture. And so as you're writing a program, one of the things that you're thinking about is, where's my input coming from? Because you'll need special commands to grab that input, process it, and then figure out where the output's going to go. So are you getting input from a keyboard, or is it a scan, like a fingerprint, face scan? Are you trying to read lips? You know, where's this information coming from? And then where do you want to display it? Is it going to be on a piece of paper, like a receipt when you go to a store and you get your receipt, or is it going to be on the screen and a receipt? Do you need any sound, etc.? So the central processing unit, it consists of you have the control unit, and then you also have your arithmetic and your logic unit. So we think of the CPU as the fetch, decode, and execute, the place that fetches, decodes, and executes. So here's a picture. The CPU is going to get instructions from RAM, and it's going to take those instructions and decode them. And then after it decodes them, then it's going to execute the instructions. So we have main memory, and main memory is, as many of you know, it's RAM, random access memory, something that we think a lot about when we purchase a computer. It's very important because it helps process information. It helps process our programs faster. The more memory we have, and many applications come with a certain amount of memory that's necessary for you to be able to run that application. So main memory, we know that it's volatile, which means that when you turn off your computer or you turn off that program, everything in RAM is just gone and erased. Memory is organized with ones and zeros. Our smallest size of memory is 1 bit. So right here it says a bit, and that can hold a value of a 0 or a 1, 0 meaning off and 1 meaning true. This is what our computer understands, zeros and ones, machine language. 1 byte is 8 consecutive bits. So, so we have 8 of these is equal to 1 byte. When we talk about main memory, we know that everything in main memory is in an address. And here's a representation, a picture of what that looks like if you were to draw it. So a way to think about it. You have memory addresses. Here we represent the addresses as a number, 4 or 5 or 6. An address actually looks like a hexadecimal number. So it's like 1EF321, something like that. But here we're just going to think of these addresses as these numbers, kind of like a mailbox. And whenever we have a value, like we want to store the number 149, or I want to store a grade of like 50 or 100, then that value that gets stored is going to go into an address in memory. And when the program stops running, or when you shut off the computer, that number, that value is going to be gone. Okay, so that was main memory. Then secondary storage is non-volatile, which means that the data stays there and it doesn't go away unless that storage device gets corrupted. So that could be something like your hard drive or flash drive. Then you have your input devices. These are going to be things, again, like your keyboard, your touchscreen, mouse, scanner, microphone, camera, etc. All these input devices are things that we have to think about, because when we're writing our program, we have to know where that data is coming from, so then we can process it. And this goes over some categories of software. So we have the system software and or the different types of system software, and then we have the application. So system software would be something like your operating system, and your application would be something that that we use for fun, or we use to help us with a task, like writing a paper or making a presentation, or for our finances, etc. So system software and application software. So if you are a programmer, you could just be a programmer that writes software, system software, or you could be somebody that creates application software. Programs and programming languages. So a program is just a set of instructions, and that's what you're going to be learning how to do, is how to write those instructions. We always start with an algorithm, and an algorithm looks something like this. It's just written in plain English, and it's just a step-by-step instructions telling us in plain English what it is that we want to accomplish. So it's a way for us to understand what we're going to be writing in machine language. Okay, so in this example, it's an algorithm for calculating the gross pay. And so it just says, okay, what is it the first thing that I want to do? Well, the first thing I want to do is I want to display a message on the screen asking how many hours did the person work. And a lot of this information as a programmer is going to come from the user. So whoever's asking for this program is going to say, what is it that they want? How do they want it to be displayed? Where do they want the input coming from? And so these are things that we're writing. We get, you could get this information from a manager, and then you go in and write this algorithm to make sure that you understand what it is that the user wants before you even start programming. And we'll talk more about that in a little bit. So that's the algorithm. It's just written in plain English. We have machine language. So although the previous algorithm defines the steps for calculating the gross pay, it is not ready to be executed. Of course not. It was just written in plain English. So the computer only executes machine language instructions. Machine language is ones and zeros. You will not be writing ones and zeros. That's very complex, very difficult for our human brains to be able to do this. What we're going to be doing is we're going to be using high-level programming languages, and then we're going to have a compiler that will convert our code into machine language. Some types of languages. We have low-level languages. Low-level languages are often written in binary machine code, zeros and ones. And then the high level, like I said, for you and I, for us humans, to be, it's just easily understood, much easier for us to be able to use. This is some of the well-known high-level programming languages. Fortran is actually the first programming language that was used on a computer. And I was just looking up some of the history of programming languages, just because of some of you might be interested in know that the very, very first programming language was actually created by a woman named Ada Lovelace, who worked with Charles Babbage on his mechanical computer called the Analytical Engine. So this was back in 1883. And more than 130 years ago. So it's the most important thing in our modern world that has happened. And it was a woman and a man that created this. So if you are a woman out there watching this video, you're taking programming, that is awesome. We don't have a ton of women in who code, and so it's exciting to find those that might be interested. And it's just, seems like mostly a man's world out there in programming. Okay, so there's our C++ language, and C++ was created from C. So, and then Java came next, and it looks a lot like C++ and C#, and somewhere in there all these came in. I don't know the exact order. Okay, see if I can get to the next slide. There we go. From a high-level program to an executable file. So you know what, there's this nice little slide here. So the previous slide just has the definition of the words, but I'll go through these steps. I like this visual a lot better. So here's what you're going to be doing. You're going to be writing the source code. So you're going to be writing the C++ source code. And this is an actual program that will run. It just outputs hello world. And you'll be doing that for your first exercise in this chapter. So when you type in your source code, then we do something that is called compiling our code. And so we have something called the preprocessor that reads the source code. And it goes through and it searches for this. If you see here, this little pound sign right there, it looks for that. And that little pound sound symbol is telling us, or is telling the compiler that you have some code out there. It's called a library, and you have some code out there, and that code needs to be linked with this program. So the preprocessor searches for that little symbol, and then it causes the preprocessor to modify your source code. So your source code is not really finished. It doesn't have all the code because there's code in this library that helps us use some of these special words that we'll talk about in a minute. So during the next phase, after our source code is modified, the compiler steps through the source code and it translates each source code instruction into machine language instruction. At this point, if it finds an error, then it stops. You have to fix the error and then start over again. If it doesn't find an error, then the compiler is going to store the machine language instructions into an object file, and the object file contains the object code. So this is the object code here. Then we have a linker, and the linker is going to link those libraries that we were talking about earlier. It's going to link it to your code. And once it links it, then it's going to create an executable file, call it .exe. And that executable file is going to contain the machine language or the executable code. .exe file is a file that you can actually share with other people. They don't get to see your code. They get to just run the program. If you want someone to see your code, you have to give them the source code, which is in the source file. And that, in our case, is going to be a .cpp file. So it will be called if you use an application to create it. And so this is the applications that we can use to create our C++ programs. I have two that I talk about on Canvas that you could use. They're called Xcode. If you have a Mac, you can use Xcode, or Eclipse can be also for Mac, Mac operating system, Windows OS, or Linux. And or like I said in my first video, you can just use the CPP shell, which is an online C++ editor. So you don't have to worry anything about installing an application and trying to figure out how to use it. So it's up to you. So the IDE, it's just an integrated development environment. It combines all the tools that you need to compile, to debug. Debug means find errors that you might have made in your program into one application. This is what an integrated development environment looks like. So it just, looks like a lot of programs where you have your toolbars and your menus. So what are our programs made of? I'm going to go through this quickly because we're going to talk a lot about these different words. And I feel like it might confuse you if I spend too much time on it. But here's an example of a program, okay? Here we've circled things that are called keywords. So keywords are reserved words. They're words that you cannot use as variables. You know about variables just like in a math class. A is a variable, C is a variable, things like that. And so, so these are reserved, can use them, but the compiler knows what they mean. So the compiler will know what these mean. Sometimes they require a library like IOStream to know what they mean. IOStream means input output stream. And so sometimes, actually, that's wrong. So the keywords don't require your include files. These right here. Your statements, like we'll talk about what does require the library file. So those are our keywords. So they have a special meaning in C++, and they're reserved words. Okay. Then we have programmer-defined identifiers. These are identifiers that you create, like hours, rate, and pay. These are your variables. And these can also be functions. Talk about functions later, or constants. We have operators. So these are our operators right here. And these are operators. So here we go, some operators. Pay equals hours times rate, assignment statement, multiplication. This here is the two less than signs means that we're going to be using it for output. We'll talk about that more later. And these are defined, the less than are defined operators. We have certain punctuation that's used in a program. So here we have commas in between these variables. And at the end of each statement, we have a semicolon, just like when you're writing a paper in English, you have periods at the end of statements. Okay. We have rules. of grammar, just like we have rules in our English language. And if we don't follow the rules, then we get an error in our program. We have to go back and debug our program. Variables. So we talked a little about variables in our program earlier. Hours worked is a variable, pay rate and gross pay are variables. So in our program, we would ask the user to enter hours worked and give us how much they get paid per hour, and then we would calculate their gross pay. In chapter 2, we're going to talk a lot more about this, but this is how you define a variable. So hours, rate, and pay are defined as double. This is a data type. This tells you what kind of variable it is. For example, is it a variable that can hold just plain integers like the number 1, the number 10? Can it hold things with decimal numbers like hours, rate, and pay? It could be, I get paid $7.50 an hour. So you have to be able to hold decimals. Or is it hold a string or a character? Those are the data types. We'll get all into data types in the next chapter. And that's what this slide says. It just says there are many data types and they hold specific types of data. So in this example, doubles call it double precision floating point number, which just means that it can hold decimals. And you'll learn a lot more about that in the next chapter. Input, processing, output. 3 steps that a program typically performs. So a program typically has to get some kind of input, whether you're getting it from the keyboard or maybe it's a game and you have a joystick. Okay. We have a process. We got to process that input. Then we have to display the results, and they can be displayed in many different ways. It can be auditory, it can be visual, it can be on print, it can be output to a file, etc. So the programming process. So number 1, we clearly define what the program is to do. This is very important. This is where we talk to the user, we talk to the people that are going to use the program. We have to know what they want. We have to really just make sure that we have those meetings. We get to draw and, make sure that we understand how things are calculated, etc. So there's a lot of time spent in defining what the program is going to do. A lot of step in the real world. Our programs are going to be tiny and small, but in the real world, the programs are very large. And so there's a lot of time spent on this. We could probably spend 60% of our time of a project. So you have a project, you can take that project, 60% of the time spent on the project should be on number 1, because you don't want to spend a lot of time coding and designing something that is not what your user wants. So then step 2, we visualize the program running on the computer. We use design tools to help us create models. We check the model for logical errors. And then, so I would say step 1 through 4, this is where all the stuff you want to spend a lot of time before you start typing the code. You type the code, you save it, you compile it, you correct any errors, and then you compile again, save and compile, run the program and test. Again, in really large programs, you have an entire department that will help you with testing. So you have other people that help you with testing. And for other people to be able to know how to test your program, you have to write test cases. And so that could be part of your job or not. Who knows? There's in programming, there's many different ways that things are broken out and jobs are given, but it could be that you do everything from design all the way to writing those test cases, all the way to testing the programs. Correct errors are found, and then repeat steps 5 through 8. And then you validate the results of the program. So this is the programming process. And again, it could be that you have a team of people doing this or that you're doing this all by yourself. It just depends how big the program is. Procedural and object-oriented programming. So we are using an object-oriented programming language. But we in this class will be learning just how to write procedural programs. So procedural programs are focused on the process. Procedures, functions are written to process data. So we're going to have small programs that have some kind of input. We'll process the input, we'll output the information. Object-oriented programming. So this is typically taught in the second half of this class. So COC 1437. And object-oriented programming, you actually code objects, you create objects. Those objects contain data, they contain methods, and they manipulate the data, but they're objects that can be reused. And so it's just a little bit different. We're not thinking about starting from the top, enter a number, add it, output it. We're thinking of an object that does something really specific, and then it can be used by other programs. And we'll talk more about object-oriented programming also at some point. We'll talk about that. All right, I think that's the end. Yeah, that's the end of this section. Make sure that you go through, read the chapter in your book, answer those small checkpoints and quizzes so you can get your points for that. And then let me start.